Inside the shadow of Geneva, under the world's surface, lies a marvel of human creativity and a potential harbinger of destruction, the Large Hadron Collider LHC. This machine is an exceptional gadget for specialists, enabling them to study subatomic particles and reveal the mysterious God particle, the Higgs boson. Well-known physicist Brian Cox has made a chilling statement that has stirred wonder throughout the scientific community, suggesting that CERN has made an important discovery with implications beyond our current understanding. Before diving into the repercussions of Cox's statement, it is important to grasp how the enormous Hadron Collider, built by CERN, works. The LHC is a 17-mile ring of superconducting magnets and the world's most powerful atom smasher. It stands as an apex of human achievement, capable of replicating the states of the universe's creation. This titanic machine allows us to unlock the secrets of the universe, revealing something genuine and potentially unsettling. CERN, established in 1954, is one of the world's most renowned research institutions, consisting of 23 member states and a vast array of experts. The LHC is CERN's central project, but it is only one part of a large network of accelerators and detectors that explore the subatomic world. The LHC accelerates protons to nearly the speed of light, reproducing the energy of the universe at the time of the Big Bang. The resulting collisions create temperatures millions of times hotter than the sun's core. With a complex arrangement, protons are guided by magnets on their journey. While advanced cooling systems keep the magnets at temperatures colder than space. The LHC's design is an engineering marvel, deep underground and shielded from cosmic radiation. The entire ring is cooled to a temperature colder than the vacuum of space, which is crucial for the use of superconducting magnets. Collisions occur at 4 points along the accelerator ring, each corresponding to one of the 4 main particle detectors: ATLAS, CMS, ALICE, and LHCb. These detectors capture the results of collisions, allowing researchers to sift through the debris in search of the elusive Higgs boson, a particle key to understanding the universe's structure. The LHC is not just a scientific instrument, but a testament to human imagination and ambition. It represents our quest for knowledge and our desire to grasp the fundamental forces shaping our universe. However, as we push the boundaries of our understanding, we must also consider the moral and existential questions that arise. What are the risks of exploring the unknown? Could our pursuit of supremacy inadvertently unleash forces beyond our control? Within the prestigious halls of CERN, where the frontiers of human knowledge are constantly expanding, a discovery has emerged that has sent shivers down the spines of even the most seasoned scientists. Brian Cox, a former scientist researching at CERN and a respected voice in particle physics, has recently made a statement that has both astonished and alarmed mainstream scientists. The goal of CERN's Large Hadron Collider is to replicate a miniature version of the Big Bang, the defining moment in our universe. Cox also highlighted the potential outcomes of this goal, noting the capacity of the LHC to develop new phenomena, including its potential to investigate dark matter by locating the Higgs boson, a substance that makes up a significant part of the universe. The possibility of replicating a mini Big Bang is more than just a theoretical idea. It is a tangible reality within the LHC. The conditions inside the collider mimic those that existed at the universe's inception, allowing scientists to observe the birth of existence itself. However, with such power comes great responsibility and potential risk. Consider the scenario where something goes wrong. In 1978, Russian physicist Anatoly Bugorsky suffered a mishap at the Institute for High-Energy Physics in Russia, where a malfunction caused his head to meet with a proton beam, resulting in severe injuries. Despite this, Bugorsky survived and continued his work, highlighting the enormous power and potential dangers of particle accelerators. The dangers associated with a particle accelerator, like the LHC, are not to be taken lightly. The potential for unforeseen reactions and the manipulation of the very fabric of reality are real concerns voiced by some in the scientific community. One of the major fears surrounding the LHC's experiments is the possibility of creating mini black holes, regions of space-time with such intense gravitational pull that not even light can escape. If the LHC were to produce such an entity, even on a small scale, it could potentially consume the Earth. However, CERN researchers have assured the public that any black holes created would dissipate almost immediately. Understanding how the LHC could create a black hole involves the fundamental mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy is so extreme that it could warp the fabric of space-time itself. Imagine a trampoline. Stretched tight with a heavy weight dropped onto it, the surface would bend, and if the weight were sufficient, it could create a hole. This analogy illustrates the LHC's potential to create a gravitational anomaly. This intriguing yet unsettling possibility has even caught the attention of prominent physicists like the late Stephen Hawking. In his writings, Hawking warned that the Higgs boson could become unstable at extremely high energy levels, potentially causing a catastrophic vacuum decay, a colossal event that could destroy the universe. Renowned cosmologist Sir Martin Rees has also expressed concerns about particle collider experiments, including those at CERN. In his book, Our Final Century, he revisits the potential dangers of collider tests, including the creation of vacuum instability. This instability could theoretically trigger a phase transition that would echo through space-time. It's causing a disaster of unimaginable scale. While these scenarios remain highly speculative, even a remote possibility warrants serious consideration. The stakes are incredibly high, and the margin for error is razor-thin. CERN researchers have meticulously assessed the potential risks associated with their experiments and implemented rigorous safety protocols and safeguards to mitigate any potential dangers. Scientific exploration inherently involves a degree of uncertainty, especially when venturing into unknown territories. The pursuit of knowledge has always been accompanied by risks. But it is precisely this willingness to push boundaries that has driven human progress. The LHC represents the culmination of decades of scientific advancement and international collaboration. Despite its impressive exterior, it lies within a realm of profound scientific inquiry fraught with potential risks and ethical considerations. The collider's primary goal of unraveling the mysteries of particle physics has brought about groundbreaking discoveries, including the elusive Higgs boson. However, the enormous energies generated within its confines also raise concerns regarding the potential dire consequences of such an endeavor. Despite the extensive safety measures in place to mitigate risks, the possibility of catastrophic events, such as the creation of miniature black holes or other unforeseen anomalies, cannot be entirely ruled out. As scientists continue to push the boundaries of our understanding, it is crucial to approach these investigations with a keen sense of responsibility, a commitment to transparency and public dialogue. The LHC, its unparalleled capabilities and potential for important discoveries, serves as a testament to human ingenuity and the relentless quest to understand the fundamental laws of the universe. However, beneath its dazzling exterior lies a domain of profound scientific inquiry, filled with potential dangers and ethical considerations. The collider experiments tap into energies and forces that are beyond the comprehension of most people. The collision of subatomic particles moving at speeds close to light creates conditions akin to those that existed in the universe's earliest moments, allowing scientists to probe the fundamental building blocks of matter and investigate the very fabric of spatial. Yet, the immense energies involved in these collisions also present significant risks, both known and unknown. One of the most pressing concerns surrounding the operation of the Large Hadron Collider is the potential formation of tiny black holes or other exotic phenomena that could have unforeseen consequences. While theoretical models suggest that any such black holes would be transient and pose no threat to Earth or its inhabitants, the possibility of inadvertently releasing forces beyond our control remains unsettling. Additionally, the sheer scale and complexity of the experiments conducted at the collider necessitate rigorous safety protocols and oversight to minimize potential risks. The global community of scientists and engineers involved in the collider's operation is acutely aware of the need to prioritize safety and ensure that all experiments are conducted with the utmost care and responsibility. The Large Hadron Collider, with its capacity to amaze and challenge our understanding of the fabric of reality, is not only a marvel of modern engineering, but also a central hub of contemporary physics. Recreating conditions just moments after the Big Bang provides a unique opportunity to study the Higgs boson and other fundamental particles. The Higgs boson, often referred to as the God particle, was theorized in 1964 by Peter Higgs and others. As a crucial component of the Standard Model of particle physics, this model describes the fundamental forces and particles that make up the universe. The discovery of the Higgs boson at the LHC in 2012 confirmed the existence of the Higgs field, an invisible field that imparts mass to other particles. This discovery was a tremendous achievement. It's validating years of theoretical research and enhancing our understanding of the universe's hidden structure. However, as with all major scientific endeavors, the pursuit of knowledge at the LHC is not without potential dangers and moral dilemmas. The energies involved in the LHC's particle collisions are enormous, and the possibility of creating new forms of matter or triggering unforeseen reactions cannot be entirely dismissed. Some scientists have speculated about scenarios in which high-energy collisions may result in miniature black holes or other exotic particles, raising concerns about the potential consequences of such events. While most researchers consider these risks to be extremely remote, the very nature of scientific inquiry involves venturing into the unknown. Brian Cox's statement highlighting the possibility of creating a miniature Big Bang inside the LHC underscores the profound significance and potential risks of this research. The Large Hadron Collider represents the pinnacle of current scientific endeavors. However, its extraordinary capabilities also spark an essential debate about the limits and responsibilities of scientific exploration. The collider, through its design and operation, seeks to answer fundamental questions about the universe. However, it also operates at the edge of human knowledge and technological capability. This intersection raises important questions about the nature of scientific risk and the ethical implications of such advanced research. One of the most exciting aspects of the LHC is its ability to recreate conditions just minutes after the Big Bang, offering a fascinating glimpse into the early universe. This simulation allows researchers to study particles that existed in the primordial universe and investigate phenomena that would otherwise be inaccessible. By recreating these extreme conditions, scientists can test theoretical predictions and refine models of particle physics. For example, experiments at the LHC have the potential to explore the properties of hypothetical dark matter particles, which are believed to make up a significant portion of the universe's mass, but remain difficult to detect. The quest to understand dark matter is driven by its profound implications for our grasp of the universe. Currently, dark matter is inferred from its gravitational effects on visible matter. However, direct detection remains elusive. The LHC's experiments aim to address this challenge by attempting to produce dark matter particles in the laboratory. If successful, this could revolutionize our understanding of the universe and lead to brand new discoveries and insights. Such breakthroughs highlight the LHC's role as both a scientific instrument and a catalyst. It's for extraordinary revelations that could alter our perspective. Another intriguing area of research involves the strong force, one of the four basic forces in nature. The strong force binds protons and neutrons within the atomic nucleus. Understanding its behavior at high energies can offer insights into the fundamental structure of matter. The LHC's ability to probe strong force interactions at unprecedented scales enables scientists to investigate the dynamics between quarks and gluons, the fundamental particles that mediate the strong force. These studies could lead to a greater comprehension of nuclear physics and the forces governing the behavior of atomic nuclei. The technological advancements driven by the LHC also extend beyond particle physics. The collider's complex systems for detecting and analyzing particle collisions have spurred innovations in computing, data analysis, and sensor technology. For instance, the development of the World Wide Web was initially conceived as a means for researchers to share data from particle physics experiments at CERN. Today, this technology has revolutionized global communication and information sharing. The advancements in computing and data management required for the LHC have had a far-reaching impact across various fields, demonstrating how major scientific research can drive technological progress. However, the operation of such a powerful instrument also requires stringent safety measures and ethical considerations. The potential for unexpected outcomes, such as the creation of new or exotic particles, necessitates a careful assessment of risks. While theoretical models suggest that the likelihood of catastrophic events is very low, the possibility cannot be entirely ruled out. This uncertainty requires scientists to approach their work with vigilance and transparency, ensuring that safety protocols are effective and that the public is informed about potential risks and the measures taken to mitigate them. Public engagement and understanding are crucial components of scientific research, especially for projects with the potential to impact society at large. The LHC has generated significant interest and discussion, emphasizing the importance of communicating complex scientific concepts to a broader audience. Effective science communication not only simplifies research, but also encourages informed public discourse about the implications and risks associated with advanced scientific experiments. By maintaining an open dialogue with the public, scientists can address concerns, dispel misconceptions, and build trust in the scientific process. As we move forward, the continued operation of the LHC and the potential for new discoveries raise important questions about the future of scientific exploration. The collider's ability to probe novel realms of particle physics may lead to new questions and challenges, pushing the boundaries of our knowledge even further. The pursuit of these frontiers will require ongoing collaboration among scientists, engineers, and policymakers to ensure that research is conducted in an ethical manner and that the benefits of scientific advancements are maximized while minimizing potential risks. The LHC remains a symbol of human ingenuity and the relentless pursuit of knowledge. It represents a convergence of cutting-edge technology, theoretical physics, and international cooperation, embodying the collective effort to understand the universe's deepest mysteries. As we advance in our exploration of the fundamental forces and components that shape our reality, it is essential to remain vigilant about the ethical implications and potential consequences of our discoveries. In sum, the Large Hadron Collider occupies the leading position of scientific inquiry, offering profound insights into the nature of the universe. Its trials have the potential to unlock new realms of knowledge, drive technological advancement, and reshape our understanding of existence. Despite its extraordinary capabilities, significant responsibilities come with them. The pursuit of knowledge must be balanced with a commitment to safety, transparency, and public engagement. As scientists continue to explore the frontiers of particle physics, the LHC will remain a testimony to human curiosity and the quest to discover the fundamental details of existence.